Imagine standing in a dense, ancient forest where the air is thick with the scent of moss and the only sounds are the distant calls of birds and the rustle of leaves overhead. Sunlight barely reaches the ground, filtered through a tangled canopy that stood for centuries, creating a world of shifting shadows and hidden movement. Suddenly a blur darts between the towering redwoods, swift, precise, and almost silent. It's not quite a bird, but something entirely new. It's a robot, flying at 45 miles per hour, weaving through branches with uncanny agility, dodging obstacles as if it's been part of this forest for years. There's no GPS guiding it, no remote control in sight, just pure autonomous flight, an artificial intelligence navigating the wild, untamed world on its own. This remarkable machine built by the University of Hong Kong is redefining what we thought possible for drones. It's the result of years of research, engineering, and inspiration drawn from the natural world. Traditional drones fail in forests, caves, or collapsed buildings, places where GPS signals vanish and remote controls are useless. They get lost, crash, or simply can't keep up. But this robot bird is different. It sees and reacts in real time, processing its environment like a living creature, adapting instantly to every twist and turn. Inspired by nature, it mimics a goshawk's fast vision, rapid processing, and morphing wings, combining the best of biology and technology in a single breathtaking package. It's not just about speed, it's about navigating chaos independently, making split-second decisions that keep it flying where others would fail. Imagine a drone that can go where no machine has gone before, safely and intelligently, exploring dangerous or inaccessible places to help us learn, rescue, or discover. This is a leap from rigid, pre-programmed machines to adaptive, nature-inspired robotics. Technology that learns from the wild and evolves with it. Where engineering meets evolution, the results are spectacular. We're witnessing the dawn of a new era where machines move with the grace and intelligence of living things. Welcome to the future of flight, where the boundaries between nature and technology are blurring before our eyes. Why do most drones crash in forests? It's all about GPS. Drones rely on satellite signals for navigation, but dense canopies or buildings block those signals. Without GPS, drones become blind, confused, and crash into obstacles. This has limited drones in search and rescue, disaster zones, and dense wilderness. The HKU robot bird breaks free from this trap. It navigates using only what it sees, moment by moment. This shift from global positioning to local perception unlocks flight in places once impossible. It's not just a better drone, it's a new way of thinking about autonomy. So how does this robot bird manage to fly through a dense, unpredictable forest, without any map or GPS to guide it? It's a question that seems almost impossible at first glance, especially when you consider the complexity of natural environments. The answer lies in three remarkable tricks borrowed straight from nature: event-based vision, a lightning-fast AI brain, and wings that can morph and adapt in real time. Event cameras work like a biological retina, focusing only on changes in the environment, detecting movement, not static images. This means the robot bird isn't overwhelmed by unnecessary information. By filtering out the noise, it processes less data and reacts much faster, almost like a reflex action rather than a slow, step-by-step analysis. Its neuromorphic AI chip is designed to handle this sparse data in just milliseconds, predicting where gaps will appear and dodging obstacles before they even become a threat. Every second, the system makes thousands of micro-decisions, constantly adjusting its path to stay on course, no matter how chaotic the environment. The wings themselves are a marvel, morphing on the fly, folding tightly to squeeze through narrow gaps, then spreading wide to slow down or change direction in an instant. This physical adaptability, combined with rapid vision and ultra-fast processing, gives the robot bird an agility that rivals its natural counterparts. It's not just about flying, it's about perceiving, thinking, and moving in perfect harmony, as if the machine itself has instincts. There's no GPS, no preset path, just pure instinctive navigation powered by cutting-edge technology and inspired by the natural world. The result? A machine that conquers the forest as easily and gracefully as a hawk, blending technology and biology in a seamless dance. It's nature's genius, reimagined in silicon and circuits, a new era of flight where machines learn to navigate the wild with the instincts of a bird. The real magic of this technology is revealed when it steps out of the lab and into the real world, where challenges are unpredictable and every second counts. Consider this: human pilots react in about 200 milliseconds, which is impressive. But birds with their finely tuned instincts can react in just 20 milliseconds, a tenfold difference. Now this robot bird? It can match those lightning-fast reactions, responding in just a few milliseconds, rivaling nature's best. That kind of speed means it can instantly dodge falling debris, weave through dangerous obstacles, or spot a survivor trapped in a collapsed building when every moment matters. Imagine a coordinated swarm of these robots searching earthquake rubble and reaching places too dangerous or inaccessible for humans or even traditional GPS drones. In the world of ecology, these robotic birds can glide through dense rainforests, tracking elusive animals and gathering vital data, all without disturbing the natural environment. Biologists can now follow rare species, study migration patterns, and monitor fragile habitats in ways that were never possible before, quietly, safely, and with minimal impact. This isn't just science fiction or a glimpse of the future, it's technology that's already transforming our world today. The robot bird is a new kind of explorer, venturing into hidden worlds and revealing places that were once beyond human reach. From daring rescue missions to groundbreaking wildlife research, this technology is revolutionizing how we explore, protect, and understand our planet. The possibilities are truly endless, and we're only just beginning to see what's possible. The journey is just beginning. The same tech could explore underwater reefs, glide beneath ice shelves, or even scout Martian caves. No GPS required. It's a tool for climate science, planetary exploration, and beyond. The real breakthrough isn't just hardware, it's the intelligent software that perceives and adapts in real time. These principles will shape everything from autonomous cars to medical robots. The robot bird invites us to learn from nature's solutions and push the boundaries of innovation. If you're excited about AI that thinks like a brain and robots that move like animals, keep watching. Discover what's next with a Square solution.